And also we continue to look at the visual question answering tasks, and I love the way they put it in this book, which I highly recommend. Now this task is answering an open-ended question given an image. So what does this say? For instance, in these examples here, you have some images and you are now posing your system with a question. For instance, you're asking how many giraffes can be seen, and you expect the system to be able to give you the correct answer, which is 2. And here you ask a question, is the bus door open? You expect your system to give you correct answer. And if you ask a question here, given your system this image, you're asking if you were to encounter this and what will you do at the stop. In other words, you are training a system that can reason with visual images, with visual content, being able to actually reason with visual content. And that's an extremely hard task. So that's what we're looking at in this session of this video. So there's several data sets for the visual question answering. You have the VQA 1, V1, VQA V2. You have the genome data set, the free multilingual image question and answer data set. Now, and they give us statistics of those data set here. Here they briefly talk about the evaluation metrics for the VQA dataset. As you can see here, to measure the accuracy, you use the minimum of these values and 1. And another thing here is that the popular paradigm approach of actually solving the visual question answering, normally they use, because you have visual, you are training your system with a pair of the image and the question. So you train your system with the image and as well as the question, then you supply the answer as the output expected. So the system is trained that way. So what do? The normal approach is image. The best way of capturing features from image is using CNN, and the best way of capturing features from text question, because these questions are text, is using the recurrent neural network. Of course, in the present day now, we now have transformer architectures replacing this recurrent neural network. And you can see here that the output that we expect that this whole system will produce is the answer, which the answer could be numeric. It could be numeric like this, or it could be another text. It could be a short text, like the one-word text, or it could be a phrase. So this is an overview of the common pattern of approaching this problem. Now, quickly, before I forget, I want to remember the evaluation metrics. So the evaluation metrics could be blue, which is bilingual evaluation on the study, if I'm correct, and we have the Meteor or CIDE. They are also used to evaluate the system as to how well it's able to get the correct answer. Now, coming back to this architecture, we could see at the high level what this architecture looks like. So you have a classifier here, and actually classify that into the correct answers. So I think that is it for this video. See you in the next one. Thank you.